I'm starting this one back to back from the cosine and sine graphs. These are our graphs of tangent. So a few key points. Our um, our graph for tangent is going to derive from the function y is equal to a tangent bx minus c plus or minus d. Same thing, a is equal to amplitude, b is going to equal to period 1 under pi over 2. So we'll just put b is equal to period. C is going to equal um, our phase shift. And then D is equal to our vertical shift. One more thing is scientific notation. So if you see this symbol, that just means all real numbers. If you see let's see. If you see something like this, that just means integer. Anything or any number positive or negative. And then if you see anything like this, that just means is. So if we say k is the element of an integer, it just means k is an integer. Any number, positive or negative. With that in mind, we will go ahead and go on to the characteristics of a tangent function. First off, a tangent function, go ahead and draw a pretty big graph here. We have our same period, 2 pi, pi, 3 pi over 2, and pi over 2. And then we go into the negatives. Negative 2 pi, negative pi, negative 3 pi over 2, negative pi over 2. And then this is just going to be our 0. And then this usually goes up 1, 2, 3, and then goes down negative 1, negative 2, negative 3. Let's see. Whenever, let me just open up a new thing here. Whoops. Yeah. So our values for tangent, x and tangent x. We're just going to go ahead and make a real quick table. 0, pi over 2, Pi, 3 pi over 2, and 2 pi. Whenever tangent is equal to 0, it's just going to equal 0. Whenever it is pi over 2, which is 90 degrees, 180 divided by 2, 90 degrees, it is going to be undefined. So we're going to have a vertical asymptote there. Whenever it's pi, it's just going to equal 0. When it's 3 pi over 2, it's going to be undefined. Again, there's another 90 degrees there. And whenever it's 2 pi, it's going to be 0. And so we can write down that our asymptotes are going to equal pi over 2 plus k pi, where k is an integer, positive or negative. That was awful. There we go. Now that we have an understanding of that, and we know that our asymptotes are at pi over 2 and 3 pi over 2, we can also assume that our other asymptotes are going to be negative pi over 2 and negative 3 pi over 2. So we'll go ahead, draw dotted lines all the way down. Now this next part, you really just need to know what the parent function of tangent looks like. I'll go ahead and show you right here. And one more. And then I guess we can also do this. So this is what tangent generally looks like. Now I'm going to go ahead and create a new one using create a new graph using transformations. We will do y is equal to negative 2 tangent x over 2. And by the way, that last graph was just y is equal to tangent x. So negative 2 tangent x over 2. Um, Another thing that you also need to know is our period is going to be pi over b. And I think I accidentally said 2 pi over b, but it's gonna equal pi over b. Let's see. So again, we'll go ahead and draw the same graph. It's awful. I would just use a ruler. I can. And we'll have right there. Yep, whatever. I give up. Um, we will have our We will be going up until 2 pi, and then pi, 3 pi over 2, pi over 2, and then over here, 2 pi, negative 2 pi, negative pi, negative 3 pi over 2, and then negative pi over 2. And then this is just going to be our point 0. We know that our the oh geez hmm um we will go ahead and say that our period um we'll go ahead and just figure out our period for now, but it is going to be we take out the 1 over 2 here, or yes, we take out the 1 over 2 here, so 1 over 2, that cancels that out, leaving us with just x in there, um, meaning it is going to be pi over 1 over 2, that's just going to equal pi over 1 times 2 over 1, that's just going to equal 2 pi. So our period is equal to 2 pi. Um, let's see here. And then if we want to find our vertical asymptotes, it is going to be, hmm, yeah, okay, so it is going to be pi over 2 over 1 over 2. And that is equal to pi. Let me go ahead and show you why that is. If you look at our um, x points on here, if we go ahead and write these out, pi over 2 over 1 over 2 is just going to equal pi, and then 3 pi over 2, or if we do um, pi over 1 over 2, that is going to give us I think that's really just going to give us anything. um, oh golly goodness, I am forgetting how to do this. Our original asymptotes would have been pi over 2, 1 over 2, and then 3 pi over 2. Um, or our original asymptotes would have just been pi over 2 and 3 pi over 2. So if we go to write that, go ahead and write 1 over 2. That's just going to equal, let's see, 3 pi over 2 times 1, which is going to be equal to, these cancel out, it's just going to equal 3 pi. And that's going to be off the graph somewhere over here. and then also all the way down here, negative 3 pi. So these are our asymptotes right here. So what you just need to do is take your original asymptotes and then divide it by b, and you'll find the asymptote for tangent. So now that we know that our asymptotes are this, we can see that this is going to be negative, meaning our graphs are going, oops, are going to be like this. The reason why that is, I don't know. It's just math. Math likes to be that way. And then our next is going to be right here. And then this is going to come down. And that is the graph for this. Y equals negative tan 1 over 2, or y is equal to negative 2 tangent of x over 2. And then one more thing, if you wanted to find the domain, it's just going to be all real numbers. However, x cannot equal pi plus 2k pi. And that is it. I will go ahead and do the next graph as well, just in case that one was a little bit hard to understand because of my stuttering. We are given the equation y is equal to tangent pi over 4x plus 2. Amplitude is just going to equal, or I guess doesn't, the number in the front doesn't really matter, but we know that's going to be positive, so it's going to be going this way like that rather than like that. Um, so b is going to equal pi over 4, and then we are also going to move up 2, so our d is equal to 2, up. We will go ahead and draw our graph. There we go. Nope. There we go. This is going to be 2 pi. This is going to be pi, pi over 2, 3 pi over 2. This is going to be negative 2 pi. This is going to be negative pi. This is negative 3 pi over 2. And this is pi over 2. Now, first we want to find our period. So period, remember, is just going to be equal to pi over b. We know that our b is pi over 4, so pi over 4. So, whoops, pi over 4. That's just going to equal pi over 1 times 4 over pi. Those cancel out. It's just going to leave you with 4 over 1, which is just 4. So our period is 4. We're going to go ahead and cross this out. That's 4. Cross this out. That's 2. Cross that out. That's going to be 3. Cross this out. This is going to be 1. And same thing with this, -1, -2, -3, and -4. Now we want to find our vertical asymptotes. Again, our original asymptotes are pi over 2, and then we just want to divide that by b, and we know that our b is equal to pi over 4. So pi over 2 divided by pi over 4 is going to equal pi over 2 times 4 over pi. These cancel out, gives you 4 over 2, or 2. And then our next one is going to be 3 pi over 2 divided by pi over 4. That is going to equal 3 pi over 2 multiplied by 4 over pi. Pi's cancel out, leaves you with 3 times 4 over 2, which is going to be 12 over 2, or 6. And these are going to be our asymptotes. So our first asymptote is at 2, and -2. And then we have another asymptote out here, which is going to be -6. And then another one out here, which is going to be +6. But we aren't really going to care about those right now. Next, this is going to be 1, 2, 3, -1, -2, and -3. We are going to be going up 2 units. So we're going to be starting here at 2, and then we'll draw a graph from there. And it is going to look something like this. Uh, Go ahead and draw the rest of that. And then same thing with this. And that is what our graph looks like. And if it helps out at all, just draw a dotted line at 2, and you'll be good to go. And that is all I have for today, I believe. Let me just check all my notes. Nope. I have one more thing, and this is just from the homework that we were given today. We had 2 problems. Name the x-intercepts for y equals tan x. So y is equal to tangent x. Our asymptotes are anything, absolutely anything pi. So it is going to be 0 plus k pi, where k is an integer. I guess we were given 3 questions, never mind. And then we are trying to find some more asymptotes. So y is equal to negative tan x plus pi. Our left asymptote is just going to be negative pi over 2, because what we have in here is just pi. If we pull out pi, um, pi over pi is just going to equal 1, or really just 1 revolution, one period. So our left asymptote left is going to equal to negative pi over 2 and negative 3 pi over 2. And I apologize real quick. This is for our x-intercepts. Let's back to this, and then our right asymptotes are just going to be the positives of this, pi over 2 and 3 pi over 2. And we do have one more thing, and that is going to be our asymptotes for y is equal to 2 tangent x over 2. Um, our b value here is going to equal 1 over 2. Period is just pi over b, so pi over 1 over 2 is going to equal 2 pi. And then again, if you divide pi over 2 by 2 pi, that's just going to give you, is that right? That is not right. Pi over 2 divided by b, 1 over 2. That is going to give you pi, and 3 pi over 2 divided by 1 over 2 is going to equal, um, oh geez, 3 pi over 2 times 2 over 1 is just going to equal, or 2 over, yeah, 6 pi over 2. Is that right? I'm doing something wildly wrong here. 3 pi over 2 divided by 1 over 2. Mm-hmm. Yep. That would give you 6 pi over 2, which would equal 3 pi. Don't take my word for that. I'm looking at this right now. I don't think it would be that. I really don't think it would be that. Tangent x. Let's see. Y is equal to 2 tangent 1 over 2 x. B is equal to 1 over 2. Yep. Pi over 1 over 2 is 2 pi. That's our period. Guess wouldn't really matter much, would it? It would not. So we have pi over 2 over 1 over 2, which is just going to equal pi, because 2's cancel out, and that just leaves you pi over 1. That equals pi. 2's cancel out here, leaving you with 3 pi over 1, which would just equal 3 pi. So meaning our left asymptotes are going to equal negative pi and negative 3 pi. And then our right asymptotes are going to equal pi and 3 pi. Why is it that way? I have no clue, but it kind of makes sense because we don't have an asymptote at 0. Alright, that is all I have for you tonight. It was kind of a long video, but I hope it was worth it. Go ahead and circle the answers for all this. There's one answer, there's two answer, and there's three answers. Alright, goodbye.